Thanks. All right. So you guys, we can get, thank you, errors in our data. So like we might go watch, our all-star basketball player, right? And the true mean, he said he makes 80% of his free throw shots, right? But then we watched and he only made 64%. And so we rejected the null, right? Well, it could actually be true that he makes 80% of his shots. And we just saw that super one weird chance, right? So we can make an error, right, in our data. So if our data or p-value is small and we reject the null, but really the null is true, we have committed a type 1 error. Okay? So that's when I was like, oh, I watched that one weird sample, I rejected the null, but really, it's true. Or like in the hearts problem that we were doing, this shoot, right? In that problem, maybe we got that one weird hand where we got 7 out of 12 hearts, and so we rejected the null, but in truth, 25% of the cards were hearts. All right, that's type 1 error. So type 2 error is if we fail to reject the null when the alternate hypothesis is true. So we got a large p-value, right? If we get a large p-value, then we don't reject the null in favor, right? So we fail to reject the null, even though the alternate should have been true. So we've committed a type 2 error. So if you draw this box, we have these possibilities. So either in reality, the null hypothesis is true, or the alternate hypothesis is true. All right, so over here, we could reject the null. When do we reject the null? Small p-value. That's when we reject the null. Okay? And we could also fail to reject the null. We fail to reject the null when we have a large p-value. All right, so if in reality the null is true and we reject it, that's our type 1 error. All right, if in reality the null is true and we fail to reject the null, that's good news, right? That's a correct conclusion. Our data gave us the right advice. All right, so that one's saying I make 80% of my free throw shots, right? And then we do the p-value, and we get a large enough p-value to say, yeah, that's right. So we fail to reject the null. That's how we say it. So correct conclusion. All right, if the alternate hypothesis is really actually true, and we reject the null, that's the correct conclusion. All right. But if the alternate hypothesis is true and we fail to reject the null, that's our type 2 error. So a couple ways to remember this. You fail to reject, type 2 error. Fail to reject is a type 2 error, okay? The other way you could remember it, if you rejected the null, that means you have a small p-value, okay? If you have a small p-value, that is a smaller number here, 1, okay? If you fail to reject the null, you should have had a large p-value, which is a bigger number, type 2, okay? those are ways to help you remember type 1 and type 2 errors. Remember that the errors are from the p-value. You got the one weird thing when really it wasn't the truth, okay? Perfect potatoes. So, a potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test using the hypotheses. The null hypothesis, P equals 0.08, that's what's expected, or the alternate hypothesis, P, the proportion of potatoes that have blemishes, is greater than 0.08. So if it's greater than, we're sending the truckload back, okay? And basically this or less is fine. We're going to keep the potatoes. We still put our null as equal to, okay? P is the actual proportion of potatoes with blemishes in a given truckload. Describe a type 1 and type 2 error in this setting and explain the consequences of each. All right. So, a type 1 error. All right, what's the definition of a type 1 error? Ginger. All right, so here's our null. And we get a really small p-value, so we reject it. However, this is really true. All right, we rejected the null when really it was true. So in the context of this problem, what does that mean? Jake. Right, what kind of p-value did we get? Well, you're thinking of p-values differently because these don't relate to p-values, right? Those are just the hypothesis. So in general, if we're going to reject the null, we have to have what kind of p-value? A really small p-value, all right? So we got a small p-value, which means we rejected the null when it wasn't true. So what kind of sample did we get? Probably one with a lot of blemishes, right? And that was a weird one. Somehow we got one with lots of blemishes, so we rejected it, all right? So we rejected it, and we had convincing evidence. We had convincing evidence that this one was true, that there was more than 8% with blemishes, when actually there should have been less. What's the consequence of that, you guys? Yep, we sent the truckload back. Bad news, right? It's going to cost money. We got to wait for that for another truckload, and we really could have used them, so that's too bad. All right, how about a type 2 error? And the way you can always memorize that is a type 2 error is that you what? Yes, fail to reject the null. Okay, when really, which one was true? Yep. All right, so we failed to reject the null when really the second one was true. So now we can go back up here, and in reality, this guy is really true. And so we should have rejected the null, but we didn't. All right? Yep. So really we had a lot of potatoes with blemishes, but somehow we didn't get that when we took our sample. So we got a large enough p-value to say that, yep, we were good, or we could not accept this guy right here. Nope. And so fail to reject the null when really the alternate is true. So what happens consequence-wise, you guys? We're going to use the potatoes, right, that have a bunch of ugly potatoes. So we're going to make bad potatoes, and we might make our customers unhappy. We might lose sales. Okay? That's it. Now let's see if we can do this one with better batteries. All right, a company has developed a new deluxe AAA battery. We talked about this one. It's supposed to last longer. All right, so we selected 15 new batteries and did a simple random sample, and we got the 33.9 hours. A significance test is performed using this hypothesis. So the null hypothesis is that the average lifespan is 30 hours. The alternate is that it's greater than 30 hours. And this time we actually got a p-value of 0.07. And so it depended on our alpha, our significance level, right? Whether or not we rejected it in that one. All right, makes sense? Now, it doesn't really matter what our significance level is in this problem. A type 1 error is the same thing, and a type 2 error is the same thing, right? Just by definition, it is what it is. So explain a type 1 error. What's the definition of a type 1 error? David, what is it? Good. Very good. Reject the null, but the null is true. So we rejected this, and it's true. So what does that mean in this actual problem? That these batteries really only last 30 hours. All right. That's truth, but we rejected that and said that it was greater than that. So what's the consequence? Fraud, right? You might market it that way, and really they don't last longer than 30 hours. So that could be a problem. All right, so for describing it, we found convincing evidence that the new battery lasts longer than 30 hours, but in reality, their true mean lifetime is 30 hours. All right, describe a type 2 error. So Chelsea, what's the definition of a type 2 error? Right, so this time, this guy is really true, and we failed to reject it. So what does that mean in the context of this problem, Kyle? Yeah, they actually last longer. Yep, that's the truth. But we got evidence that it was 30, right? So a consequence of that, this time they actually last longer. What do you think, Jake? Let's see. So we failed to reject. So that's a large p-value. Yeah. Anyone have a good consequence for that? What do you think? Yeah, that could be true. You're losing out on sales because you're marketing it as the same time, right? Or you're putting more money in to maybe figure out a way to make them last longer, right? So type 2 error, not finding convincing evidence that the new batteries last longer than 30 hours on average, when in reality their true mean lifetime is greater than 30 hours. So a consequence of a type 1 error would be that the company spends the extra money to produce these new batteries when they aren't any better than the older, cheaper type. A consequence for a type 2 error would be that the company would not produce the new batteries even though they were better. So they said they just wouldn't even produce them. Interesting, even though they're better. Okay. However you want to explain your consequences, as long as it makes sense, works for me. Okay. That's it, you guys. You're gonna